Yeah, welcome to reality, peeps. What do you mean? So coma? You put coma? Well, really, you're... Okay, let's not get into that. Okay. Some things would be a higher percentage. Okay? So... Yeah, it's awesome. Some things are going to have a higher percentage than others, right? I know. So some things, because of repeated behaviors, get a higher percentage, right? So what's the percent chance that I will probably say something smart mouth today? Pretty high, right? Based on past behavior, okay? When they go to calculate the weather, they take into consideration storm fronts and extra kind of things. So some things are better described as a percentage, okay, of chances of happening because you have some outside kind of things that might affect it, all right? So Andrew brought up a good example. I said, what's the probability that you're going to wake up tomorrow? 1/2. He kind of added a, well, what if? And that's real life, right? Like sometimes there's a, well, what if? So you have to be careful. This is probability is an area called statistics, okay? In high school we just do basic probability, but we'll do, thanks. We'll do some statistical analysis, which sounds really fancy, but it's basically fractions and percents and trying to understand about things that might be related and things that won't. This is one of the more useful things to people in America, not who have graduated from high school or not. If, as any kind of functioning, thank you TJ, functioning member of society, you have looked at a newspaper or you are a student in Portland Public and they're talking about the percent chance that you're going to graduate, that's a probability. So what are some of the things that affect a, what are you guys, 14, 15? Yeah. What are some of the things that would affect a, let's say, 14, 15, or 16, we'll kind of give a range, okay, would affect graduation rate in Portland Public Schools? Raise your hand. Tell me something that would affect that graduation rate in Portland Public Schools. Quinn?
Gang activity.
Gang activity, okay? So Portland Public Schools classifies those as risky behaviors, right? So gang activity, drug activity, school skipping, that's what Portland Public classifies as risky behaviors, okay? So yes, that statistically affects graduation rate. What else?
Dropping out.
Yeah, that would be skipping leading to dropping out. So yes, in that risky behavior category. Haley? Strikes? Well, since your teachers have never been on strike, it wouldn't really, yeah. If it did, yes. But since it hasn't happened, it wouldn't, like as of today, affect yours. Okay. In the future it could, but not as of today. Charlie? Say again? Illness, absolutely. So that goes into attendance, but it's not really a risky behavior, right? Because it's not something that you're doing on purpose. I don't think anybody says, hey, I'd really like to have stomach flu and be puking for 2 weeks. Nobody's, well, people might, I don't know. But illness, absolutely. Dominic? Depression. So, and that would go under illness, right? Something that people do not choose to have, absolutely. Kalasia?
Teen pregnancy.
Teen pregnancy, absolutely. Definitely not an illness. It's not an illness, so it's a separate category. You're right. What else? Something very obvious.
Oh, bullying. Right?
Bullying.
Maybe.
Terrible teachers. I don't know where you're going with that, but possibly, yes. So could be outside, like disengaged from school, had a really bad experience, had a couple miserable teachers, became credit deficient, absolutely.
Like drugs.
Yep, we put that in the riskies.
No.
Not paying attention? Yeah. Absolutely. You went every day and you just kind of sat there and stared into space. That is going to affect your graduation. Absolutely. So there's some personal behaviors. Okay. What else, Quinn?
Weather patterns, whether it's going to snow and that would prevent school from opening.
Yep.
Oh, yeah.
Haley? Absolutely. What's going on at home, right? So if you have a parent with substance abuse, that can affect. You have parents that have been incarcerated, that can affect. You have custody issues in your house, like you have to be with mom, with dad, with grandma, that can affect graduation. You have to live with a different family, like your family has financial issues and you have to go live with aunties or uncles. Absolutely, that totally affects. What else? Andrew? Not caring, which might kind of tie in with what Moises said about just not paying, maybe. And it could also tie in with what Dominic said about depression too, right? So there could be some bigger issues there. There's one really big one that Portland always talks about.
Oh, traffic.
Well, that's true, but not really.
Do you mean like human trafficking or car trafficking?
Car trafficking, yeah.
Car trafficking, not so much. We don't have that bad of traffic that you can't not graduate because
Yeah, really hard.
that's after school.
I guess it would be a problem
So
for
cute, Kalasia. Haley. Absolutely, so peer choices. And that kind of goes into the risky because some of you have some peers that are risky. Yeah.
I feel like we're not going to get this obvious one. I don't know what the percentages are.
Why are you touching my hair, boo?
Not a guess. Venus, looking at your fingers. Okay. Yao? Bullying is absolutely part of it. Yep. Suicide is part of. Suicide kind of goes along with depression a lot of times, but bullying, suicide, all those things. Will? Yep.
Got noticed that's a big one he's talking about.
So let me be very blatant about it. So in this classroom, why would Charlie have a better chance of graduating than Rodney?
Wait, what? Whoa.
White racist.
Wait, what?
Racism.
He's good at construction.
He is. If we gave diplomas for construction, then that would be it, okay? But Rodney's not bad. Just saying. So statistically, in Portland, okay, and when we talk about statistics, we are not talking about Charlie, okay? Charlie does not represent every white boy in high school in Portland, okay? And therefore, Rodney does not represent every Indian American boy in, or do you just track Indian? I'm sorry. Indian American, Indian. Okay. So then Rodney is not the face of every Indian. It's not like you should be like, I have a question about India. Hey, Rodney, what do you think about it? It should not be just Rodney is the representative, right? Or Yao is going to represent every African country that possibly, right? Or Mexican? Yeah. So just Jose, just translate this for me. Like that should not be how we look at race. However, your race in Portland Public Schools directly, severely affects your graduation rate. White students in Portland Public Schools graduate at more than 2 times a greater rate than any other group of students. Why? Lots of reasons. It could be a long list. They're smart. Yep, that's it. I think you just made like a huge sweeping generalization. And no, it is none of the reasons are intelligence.
Because the school system
Yeah, but the rate doesn't have to do with how many.
capitalistic. Probably.
One.
Just trying to control.
Mr. Davis.
Trying to make
Yeah. Oh, and there's,
Librarian.
No, and we have a black tent. And then we have our security guards. They're both black.
Oh, yeah. The librarian.
okay. Before we get into a huge racist discussion. So, I will say that, listen, the population of students at Benson is the most racially diverse in the entire state. So when you look around this classroom, and whether you know exactly what country of origin or heritage people in here's families are from, okay, that this group of 34, or today we have a little less, faces is not how most schools look, especially high schools, okay? So when you go, just be quiet, please. When you go to most other high schools, it would be about 20 of us would be white, and then there would be a couple other races. Whereas in here, the number of white people is far outnumbered by people that have brown or darker skin. Okay? So that is not true. However, what TJ and Michaela were talking about, most teachers in Portland, not just at Benson, are white. Throughout all grades, K-12, okay? So when Will asks why, that could be part of the problem, right? It could be that there's a lot of students in Portland Public who have never had a teacher at any point of the same race as them, right? Which maybe contributes and maybe doesn't, because a lot of kids are still very successful, but some kids not so much. So that could be part of it, okay? You could also look at neighborhood schools. So where there is a large, predominantly white population and how those students do on like state tests, okay? And I'm talking K, 1, 2, 3, 4, 5th grade, versus a school that maybe has mostly African American students or mostly Hispanic students, or maybe just mostly not white students, and how they look, okay? And how they do on standardized tests. And I'm not just talking about high schools. So part of it could be that too, okay? And Benson, like I said, is very different. So statistically, the fact that we at Benson have the second, or we're tied for second, for graduation rates in the district is, Lincoln is first. Don't suck your teeth. They're at 86, we're at 85.
Oh, so we're second?
We're tied for second with Grant.
Oh, we're tied for Grant.
Oh, no.
But you think about, and maybe you didn't even know that when you came here. So if you think about, if I am a person of color of any kind, and I chose to go to my neighborhood school, okay, maybe you graduate still. But why, what is it about, and I don't want you to answer, I just want you to think. What is it about Benson when we have so many students of color that are not white at Benson? What is it about what we do here that makes our graduation rate so much greater than basically almost all the other high schools but Lincoln and Grant, which are very, very white, okay? So you have to think about, and whether you, some of you are not a person of color, so it maybe doesn't even matter to you, but in the long run in life it will matter. If that was not one of your reasons for coming here, maybe it was, maybe you knew that, and maybe you didn't, and you're like, whoa, I guess I made a good choice, because you did. You did. Your chances for graduating, and this is for every student, because we have a phenomenally high graduation rate, whatever color your skin is, chances of you graduating from Benson, if you stay here and do the work, really, really good. Really good. Are they 86 and we're 85? Or they're 87 and we're 86? Whatever, it's really good. You all have got enough tests. You know 86% is pretty good, right? So that's graduation. But it's also 15% that don't make it, right? So look around. There you go. 15% of you won't make it.
90%.
Charlie.
Yeah, but percentages don't change.
Yeah, the percent graduation rate is only based on, so out of how many students you have, how many of them graduated. So the percentage rate does not, is not affected by the population size of your school. That was a very good question.
Just like we're bigger than some other high schools too.
Yeah, bigger building.
But some other high schools.
We're about in the middle.
Yeah, we're about in the middle.
So Grant is bigger, Lincoln's bigger, Wilson is bigger, Cleveland is bigger, but that's it. Also bigger. And then everybody else,
Franklin's bigger.
oh, Franklin.
But Roosevelt-
I've seen Jeff has more buildings than I.
Why is Franklin big? Because they closed Marshall. Supposed to know about probability from 8th grade. Who knows whether it happened or not? So I'm going to make sure that we go over it again, okay? So just so you know that that is happening. Top, please. Okay, so before we start, in your notebook, okay, there are 3 basic, thanks for writing this down. There are 3 basic models for probability, okay? 3 basic models for probability. That's what we're going to cover today. Thanks for writing this down. First, there is the ever popular and really painful list. Then we're going to make a tree diagram. And then an area model. Okay? So these are the 3 that we're going to be reviewing today. So these are things that you may have seen before. Okay? You may not have seen before. I'm going to go over them fairly briefly today and run through a few examples to either refresh your memory or teach it to you, whichever status you are in. Okay? You do not have to memorize what they are called. However, if I say to you, make a tree diagram, you need to know what that means. Okay? If I say make an area model, you have to know what that means. Okay, so now let's take a look at this paper, please, that has the playlist on there. So, this is an MP3 player. I cut off the girl's name on accident, so I don't even remember whoever's. This MP3 player can be programmed to randomly play songs from her playlist without repeating a single song, okay? So most of you have ever seen in your life some kind of playlist where you can put it on shuffle, right? And it doesn't... Shabar, were you done so you can actually get the directions, or did you want to comment? You done? No? Okay, keep going. We'll just wait for you then. Are you done? Oh, great. Okay. So what's the probability that her MP3 player will select a country song, okay? So here is her playlist. No, these are not real songs. I Love My Mama, Country by Strings of Heaven. Don't Call Me Mama, Country, a duet by Sapphire and Hank Tumbleweed. Carefree and Blue, an R&B song by Sapphire and Prism Escape. Get it? Yes. Go Back to Mama, duet by Bjorn Free and Sapphire. And Smashing Lollipops by Sapphire. Okay, so what I want you to try right now are these 4 questions. What is the probability that her MP3 player will select a country song? What is the probability that Renee, oh, there's her name, Renee will listen to a song with Mama? Those 4. In your tables, you got 2 minutes. Yep. Probability that her MP3 player will select a country song. And your answer was? 2 out of 5. It needs to be written like a fraction. I'm going to say that again very clearly. It needs to be written like a fraction. Second question, what is the probability that Renee will listen to a song with Mama in the title? 3 out of 5. Third question, what is the probability she listens to a duet with Hank Tumbleweed? How many did you say? Oh, okay, sorry. There was some mumbling, just making sure you only said one. I thought maybe you thought Hank was very popular. Next question, what is the probability she listens to a song that is not R&B? 4 out of 5. Okay, so making sure that you're reading those questions. Okay, here is a list activity. All right, it says, while waiting for a bus after school, Renee programmed her MP3 player to randomly play 2 songs. Okay, something off of her 5-song list. She's just going to listen to 2. And it will not play the same song twice. So you wouldn't hear, I Love My Mama, and then I Love My Mama again, right? It would be 2 different songs. Here is your list activity. You are going to list all the combinations of 2 songs that Renee could select. The order that she hears the song does not matter, meaning if she heard song A and then song B, you wouldn't also have B and then A, okay? So the combo of A and B together should only count once, all right? So down here in this extra space, start listing them. So A and B is already one combo, I gave you that. And then start to make a list of all of the possible combinations for the 2s that she could have, okay? Like A and B, A and C, A and D. Go ahead and take your hood off. 10. Whoa, hello. Anybody got them written out clearly that I could put up on the overhead? You feel like you could show Kalasia your 10? Well, you might not be the only one. It's okay. I'm glad you get it, though. Good. Okay, so here is an example of a list. Okay? When we say that a list is a strategy for probability, the list does not have to be fancy. It doesn't even have to be this neat, really, although this is quite neat and organized. But this is a strategy, okay, for figuring out probability. And then if I said, how many of these have B in them, you could more easily figure out, well, out of my 10 total, however many, 1, 2, 3, 4, 4 of them have B played, okay? Questions about the list? All right, turn your paper over, please. We're looking at the goofy girl with the big old glasses. Yeah, this girl looks scared to be on the bus. I'm just a little nervous. Okay. Second kind of diagram. Here we go. It says, to get home, Renee can take one of 4 buses, the 41, the 28, the 55, or the 81. She obviously does not live in Portland. Once she is on a bus, she will randomly select one of the following equally likely activities. Listening to her MP3 player, writing a letter, because so many kids do that on the bus, or reading a book. Also, so many. Although it could be like on a, I don't know, a Nook or an iPad. Okay, so list all the possible ways Renee can get home. Use a systematic list to make sure you find all the combinations of a bus and an activity. So the exact same thing that we just did about listing, I want you to do a list right here in this space, like 41 and MP3, 41 and letter, or something like that, okay? So all of Renee's, see what you got? Good, 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 good. Oh, yes, yes. Yeah, yours was okay. You had a long list. How many you got total? 12. Okay. All right, so do part B. Using your list, you're going to find out those probabilities, okay? The probability Renee takes an odd number bus, the probability that Renee does not write a letter, watch the wording, and number 3, the probability Renee catches the 28 and reads a book, okay? So using your list and your 12 options, you're going to do number 1, 2, and 3. 12, which is the same as 3 out of 4 if I reduce. So important point of clarification, thanks for listening, is that 9 out of 12 is an acceptable answer. And 3 out of 4 is an acceptable answer. Okay, number 2. What's the probability Renee does not write a letter? 8 out of 12, which could also be the same as 4 out of 6 or 2 out of 3. Any of those equivalent fractions would be acceptable. And then number 3, the probability that Renee catches the 28 and reads a book. 1 out of 12. What? Wait. What? So you're telling me that you think 1 out of 12 is the same as 12? So if I give you a 1/12 of a pie, that's the same as 12 pies? You should not be just saying, because that's not good. Ah. Yeah. Okay, at the bottom. This is a tree diagram. Okay? This is the same kind of problem. However, they use a tree diagram to explain it. Okay? So this is just a different way. So we're going to do a sample problem this way. Please stop talking so I don't have to talk over you. So these would be her 4 buses. She takes the 41, the 28, the 55, or the 81. And then off of each one of these, she would have her 3 branches. She could read, write, do a letter. Read, write, do a letter. Read, write, do a letter. Okay? So some people, as we're going to work with tree diagrams, really like this because 1, they hate fractions, and 2, they really suck at lists. Like they always forget one. Like everybody at their table came up with 12 and they got 11 and they can't figure out which one they missed, kind of thing, right? So it's hard to keep track of. So these 12 here, 3 plus 3 plus 3 plus 3, or if I just counted them up, this is my 12 final choices. Okay? And then, well, how many of them were reading? I could just count up my little R's for reading. So this is an alternative to just making a list. Okay? It's another option. So let's look at a problem where we could make a tree diagram. Mr. Harishu should have just handed you a paper. Let's look at the first example up there, please. Thanks. We're looking at number 1 where Keisha has 4 favorite shirts. So, focus. If Keisha has 4 favorite shirts, I am going to start my tree diagram this way. 1, 2, 3, 4. Do what I do. Okay? She has 4 favorite shirts. So in my tree diagram, I'm going to have 4 branches. Jesus, you got this? So then on each of the branches, I'm going to name each one of those a color or a letter. So blue, green, red, and yellow. So that I know in my diagram, each one of those branches is indicating a different color shirt. And then she has 2 favorite pairs of pants. So she's going to have a shirt and pants on, thank God, so that each one of these is going to have 2 branches off of that. So one is going to be black and one is going to be brown, however you make your black and brown and black and brown, black and brown, black and brown. I don't know, he's just disrupting your educational environment. So I've got 4 shirt branches, and then off of 4 shirt branches, each shirt could be worn with a different pair of pants. So then this diagram, instead of making a big long list and being like, she could have a blue shirt and black pants and a blue shirt and brown pants, and That might not even match. And then a green shirt and black pants and a green shirt and brown. Whatever it is.
Really? Oh, drop that beat. Yes, Ms.Slaughter.
Is that like a real song or is that just like a ringtone thing? Okay. So then this could possibly be easier than making a big long list because I can look at this now and how many outfit choices does she have? 8. So those final branches are your final outfit choices. Okay? So your final branches are your final outfit choices. All right? Anybody unsure of where I got 8? Yeah. Okay, so number 2. Number 2 says each morning, Aaron starts his day with either orange juice or apple juice, followed by cereal, toast, or scrambled eggs. Use the space down here at the bottom. For number 2, I want to see a tree diagram. Use the space at the bottom for number 2. I want to see a tree diagram. 6, great. Do number 3, same way. For those of you that need a little bit of a visual, number 2 should look something like this. Stop talking. Number 2 should look something like this. Apple juice, orange juice, and then your 3 meal choices. The correct answer was 6 meals. So not only do you have to have your diagram, but you also have to have the answer to the question, right? Your diagram is not the answer. Okay? So then the second one, the diagram could look like this. It could look differently, but this person used cone and dish, and then vanilla, tutti frutti, and chocolate. I don't even think tutti frutti is a real flavor, but whatever. And then, it is? That's sherbet then. That's not tutti frutti.
There is one called Tutti Frutti.
Okay, that is not the significant part. So the question said, what is the probability she'll be? So the question said, what is the probability she's going to eat tutti frutti ice cream from a dish? So I'd have to go dish, tutti frutti, and then I should have some kind of fraction on there. Okay? Questions?
This may be the only thing.
Charlie? Yes.
Thank you.
Yep. Can I see yours? So Charlie, I'll ignore the hole in the paper. Charlie asked this, is it okay if I did mine the other way? So he started with 3 branches. He started with vanilla, tutti frutti, and chocolate first, and then did cone dish, cone dish, cone dish, but would come up with the same answer. It's still going to be 1 out of 6. So Michaela, that's what you were asking before. Did it matter if you started with 3 or 2? And until you see both models, sometimes it's hard to understand that both of those are actually okay. Questions about that? Okay, we're going to do a little bit with dice. In your notebook, please. In your notebook, please. Okay. There are generally only a couple kinds of dice problems that you should have seen at this point. Write this down in your notebook. Nope, you can put it right under the probability stuff. Okay? And most of the time the question should say, or you should assume, that we're talking about rolling 2 fair dice. So just to be clear, fair means that they're not weighted. I'm sure you all have seen some movie or heard about somebody cheating at rolling dice. These are just even, normal dice. Nobody's manipulating them in some kind of hustling you out of your money way. Okay? And just to be clear, dice have the numbers 1 through 6 on them. Okay? So these are normal, 6-sided, just to be sure. Okay? So the question says, what is the probability that the sum of the 2 dice is less than 4? Okay? I'm going to do 2 different models. I want you to write down both of them. So first I'm going to do a tree diagram. Okay? So first, my first die is going to have maybe a 1, maybe a 2, maybe I roll a 3, maybe I roll a 4, maybe I roll a 5, maybe I roll a 6. You should be writing this down. Okay, so that would be my first roll or my first die if I'm rolling them at the same time. And then the chances of the same thing happening on the second die, because the question says fair, is exactly the same. So if the first die is a 1, the second die could be 1 or 2 or 3 or 4 or 5 or 6. Okay, and the same thing could be true for number 2. 1 or 2 or 3 or 4 or 5, and now my diagram looks crappy. No, I want you to do it. Maybe yours looks better. Okay? So the reason for me modeling it this way is because sometimes the tree diagram is not the best. If you are really good at a tree diagram and every time you do a tree diagram you get the right answer, please do a tree diagram. But sometimes it's not the best model. Okay? So underneath here we're going to use what's called an area model. So we're going to set up a rectangle, and it's going to have 6 boxes this way. 1, 2, 3, 4, 5, 6. Okay, and yours can be as big or as little as you need. And it's going to have 6 boxes this way. Start to set up my area model. First of all, it's always going to be a rectangle. Okay, so it's always going to be some kind of box looking thing. And on the top, I'm always going to have whatever choices are from one part of my probability problem. So one of my die choices up here, 1 through 6. And then over on the other side, my other choices for probability. Okay, so because this one has 2 die, I've got 1 through 6 on the top and 1 through 6 on the side. What did the problem ask you about? So 4 people know what the problem's asking? What's the problem asking? Is it asking you to multiply, add, divide, subtract? Add. Okay? So I could fill this in. If I was going to roll a 1 and a 1, my sum would be 2. If I was going to roll a 2 and a 1, my sum would be 3. This would be 4, 5, 6, 7, right? I could fill in the entire table. And I could go this way and be like 3, 4, 5, 6, 7. This would be 4, 5, 6, 7, 8. And I could fill in the entire table because I know how to add up numbers. Okay? Why could I stop where I stopped? Yeah, it says less than 4, right? So if I'm going back to my original question and it's asking the sum is less than 4, how many of those do I have? The sum is less than 4. 3, right? This number is less than 4. This number is less than 4. And this number is less than 4. 4 is not less than 4. 4 is 4. Okay? So that means this is 3 choices. 3 of my choices has a sum less than 4. However, I said in the beginning, I really would like it to be a fraction. So somebody raise your hand and tell me, how do I figure out the number on the bottom of my fraction? Raise your hand when you think you know. How do I figure out the number on the bottom of my fraction? 3 out of how many? Thanks for raising your hand and waiting. Yeah, what do you got?
3 out of all the possibilities.
Yep, and how many possibilities do I have?
12, 13, 14.
36. So a couple different strategies on figuring out 36. Yao had one. He was going to count them all. Totally fine. If you're in doubt, please count them. Shortcuts, anybody other than counting? I mean, I know for a fact you can count to 36, so you would have come up with the right answer. I have great faith in you. But there might be something a little bit faster than that. Andrew, shortcut?
You know, there's 6 boxes by 6 boxes, so you just do 6 times 6.
Yeah, and so that part of that is the area, right? So Andrew's kind of saying, well, 6 is how many is on top, and 6 is how many is on side. So 6 times 6, I know 36 is going to be the bottom. Okay? Or 6 rows of 6, 36, 6 columns of 6, 36. Please take your hood off. I'm not calling on you now. Sorry. You need to do what I ask. It's not that hard. So my area model is going to look like that then for dice. Okay? Questions? You're going to do one more. So on this paper that's got Tutti Fruttis on the front, turn it over. Find number 2. Number 2. Number 2 says 2 fair dice are thrown. What is the probability of getting 2 6s? Draw a probability tree and table. So I'm giving you a choice. You can either do a probability tree or a table. I don't care which one you pick. Okay? So you either do a tree or a table to show me your work, and then answer that question, what is the probability of getting 2 6s? Okay? It is not enough for this state standard to just have the answer. You have to be able to diagram it or model it. So you're going to pick a tree or you're going to pick the area model and answer that question, please, with a diagram. Possible area model.
Is it right?
Yeah, that's why I picked it. So the question says, what is the probability of getting 2 6s? That means a 6 on the first die and a 6 on the second. That only happens one time. That's when the sum is 12. Even though Rodney said that 4 plus 5 is 12. It's cool. It's cool, Rodney. We all make mistakes. I spelled probability wrong earlier. Okay? So 1 out of 36. This is the only box right here. This is it. This is the only time you hit 6 and 6. That's it. It didn't say anything about sum. Okay, in your notes, next set of examples. Wheel. Thank you. The other use of an area model is multiplication. Please write this down. It is when you have a union of events. It does not mean like a marriage. It's not that kind of union, okay? Union of events means 2 events that combine. All right, so we're going to do an example. So, 50% of the students pass their test. We'll say pass G7. Right? And 75% of the students had breakfast that morning. Okay, so 50% of the students passed G7 in class, and 75% of the students in the class had breakfast that morning. So, what would be the probability that a student passed and had breakfast? Okay, so this is getting to what I was talking about when we started class, right? All of those things that go statistically into graduation rates. It's never just one thing. It's always the union of events, maybe more than 2 usually, but this is the kind of probability that we should be working towards. Okay, so everybody okay copying so far? All right, so my area model is going to start out to be a rectangle again. Okay, and I'm just going to do it 4 boxes. Okay, if you later want to modify that so that you have bigger boxes as a bigger percentage, fine, but really, nobody cares. All right, so up on top, I'm going to have 2 groups of categories. Students that passed, and then the other group would be students that did not pass. Okay, and then over on the side, I would have some students that had breakfast, and then my other group would be no breakfast. Okay, so my diagram does not have to be overly complicated. My groups are not, maybe had breakfast, had 2 bites of a friend's. No, it's not. Don't make up little weirdo scenarios, okay? Ate something off the floor, I don't know. It's either breakfast or no breakfast, passed or no passed. Okay, here's the part that's going to hurt your souls, some of you a little bit, but you're going to be okay. You have to use fractions. You're going to be okay. If I say, what is, looking at this percentage, what is this as a fraction, 50%? 1/2. So I'm going to, above my past, write 1/2. Thank you. And if half of them passed, then no pass is a half also. Okay? So 75% of students had breakfast. What's that as a fraction? 3/4. So the 3/4 is going to go here, which means not having breakfast is 1/4. Okay, however much is left. Okay, so the good news about statistics and fractions is you only have to multiply the fractions, which is the easiest part of fractions ever. Okay, there's like no fancy rules, nothing. So in my box, on the first one, I'm going to show you how I got my number, and then the rest of them I'll just kind of run through a little bit faster. So in order to get the number or the fraction that goes in here, I'm going to take my 3/4, so this 3/4, and I'm going to multiply it by my 1/2. Okay? No. So in fractions, you always multiply the top 2 numbers together. So on top, you're going to do 3 times 1 is 3. And then the bottom 2 numbers, 4 times 2 is 8. And that's it. Okay? That's multiplying fractions. And that's all you're going to need is multiplying. We're not going to be dividing or doing anything else weird. Yes. So this is also going to be 3/4 times 1/2. Well, we already did the math on that. So this is also 3/8. Okay. So no breakfast is going to be 1/4 times 1/2 here. So on top I've got 1 times 1 is 1. And on bottom 4 times 2 is 8. And this one's going to be the same as well. So before we even look at answering the question, is there anybody unsure about how I multiplied the fractions, where I got my fractions from? Okay, so then go back and look at the question. The question said, now that I have my model all done and I got my math all done, I have to go back and look at my question. What is the probability that a student passed the test and had breakfast? 3/8. So you could circle, but you should also somewhere over to the side write 3/8 out as your answer. Everybody okay with that so far? Okay? All right. So keep that out because you might need to look at it. Mr. Horatio came around with 2 pieces of paper, one that had a lot of words on it and one that had kind of some empty boxes. So you should have 2 pieces of paper that look like this. So up at the top, one way to represent a probability situation that has outcomes with unequal probabilities is by using an area model. Okay, so area model of multiplication, that's what we just worked on. Basically, it's a square, blah, 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 blah. Okay, here's our question. For example, everybody with me on this paper where it says bend thumb, roll tongue? Okay, up at the top it says, for example, 1/4 of the United States population, so everybody in America, can bend their thumbs back. What does that mean? No, I'm not talking about double jointed and other weird things that you're now all going to attempt to do with your thumb. So there is this genetic trait. It is not because you're superhuman or your thumbs are flexible or one time you broke it. It has nothing to do with that. You're either born with it or you're not. That your thumb, when you hold it up like this, bends back. Mine does not, so I can't use it as an example.
Does Moses?
How
Nope.
do you tell? How do you tell?
Megan,
That back.
Colleen, definitely. Come here, Colleen. Let me use your thumb, please.
Wow.
Either, and it's not like Dominic is special, but you are. Hold it up so they can see. Okay, so literally, Colleen, bring yours over here too.
It looks like a cheetah.
It literally goes straight over. Okay, it's not like, oh, mine bends a little bit. It goes straight over. Thank you both so much.
I can't.
Oh no. Yeah, everyone wants to.
Yes, Sophina, she
Everyone
can't
wants.
do it.
Sophina, you can't?
Not a lizard.
There's usually, so 70% of the people in the U.S. can do it, okay? And I don't know about the world, but 70% of them in the U.S. can do it. You're just born with it. It's not something you can learn. So even if you learned how to do it, your tongue has always had the ability. It has something to do with you either have it or you don't, like the thumb thing, okay? So on this diagram here, okay, so this is your second paper. Refocus. This is your second paper, the one that just has a big diagram on it. We're going to make a line about here. Okay? And roll tongue, yes, is about 7/10. Okay, so add those numbers on there. And so that means people that can't roll their tongue is about how many out of 10? 3.